Hi, it's Dave Duggal, EnterpriseWeb. Today we're going to talk about enterprise-grade generative AI and how our no-code platform streamlines the integration, use, and management of LLMs. No more static one-off RAG pipelines, no writing custom Python code, no one-off manual integrations. We're going to show you how we simplify and automate LLM interactions with a platform-based workflow. Before we do, let's refresh on EnterpriseWeb. EnterpriseWeb is an AI-enabled no-code platform for intelligent business and infrastructure applications. Unlike other no-code platforms, which target the citizen developer looking to develop simple applications where any moderately complex functions or integrations require IT, EnterpriseWeb was designed from the ground up to support complex distributed systems and real-time data-driven applications. We target the systems engineer, the solution architect, and the data scientist. EnterpriseWeb is a knowledge-driven orchestrator that leverages a hypergraph. A hypergraph is a kind of graph technology that supports complex, multidimensional, and even conditional relationships. So it allows us to model complex business operations. And we use the graph to interpret events, automate decisions, and optimize actions based on real-time context. EnterpriseWeb has 21 awarded US patents and multiple patents pending. Under the hood, EnterpriseWeb is some pretty sophisticated computer science, but all that is done in order to simplify the user experience so that the developer can declaratively compose with no code complex applications rapidly and accelerate service delivery. Our thesis is that businesses need an enterprise web. It's an umbrella abstraction that logically connects increasingly fragmented business operations. As a business user or as an engineer or an architect, you'd like to look down on the enterprise and see the people, the information, and capabilities that comprise it. You'd like to be able to flexibly compose them for purpose and not be caught up in all this tight coupling and static flow charts that make things time consuming to develop and deliver, hard to change, and expensive to maintain. Enterprise Web acts as a single source of truth for the design, deployment, and management of complex distributed systems. The knowledge base provides shared domain semantics, metadata, and state information for intelligent orchestration, configuration, and workflow automation, and policy-based management. The fact that we have domain semantics, metadata, and state means that the objects in Enterprise Web are actually really digital twins, that we can actually observe and monitor these elements, maintain their state in the system, and even retain their historical state so we can do predictive analytics. The platform features a unified interface with a central catalog, a design environment, and common tools for IT to improve collaboration and IT productivity. If you were to look at Enterprise Web's conceptual architecture, if you were from the engineering side or the development side of the house, you might think it looks like a cloud-based IDE in the sense that it has a design environment, an object modeling environment, an onboarding environment. On the right side, if you look, it has all these platform services that look a lot like middleware components in a traditional deployment. And in the center, you see the graph, and the graph here would represent a DSL or a domain-specific language. So in a common parlance, this would be an integrated development environment with a graph-based DSL and an integrated execution environment. So that would be a comprehensive offering as it is. But Enterprise Web, what's interesting here is Enterprise Web does this all in graph. The design environment, the object modeling environments are all just projections from the graph. We dynamically construct the UIs. The functionality on the right side, the platform services, all those things that look like middleware components are actually just software patterns that are persisted in our system as declarative expressions or serverless functions inside Enterprise Web. They actually live inside the graph as well. And in this way, we have data and code co-resident in the same graph. And that's a powerful thing because it means that code can reason over data and data can configure code very efficiently. And that's what allows Enterprise Web to dynamically construct pipelines based on interaction context. And we do all of this, onboarding, design, composition, all the middleware capabilities, the modeling, all in 50 megabytes. You can deploy in the data center, deploy on a laptop, deploy out at the edge, and Enterprise Web nodes can even be connected in a mesh architecture so they can actually act as what we call an application fabric. So you can actually have interoperability across enterprise web nodes. Now, under the hood, enterprise web is actually using agents and, as I said, stateless functions with a graph to deliver and digital twins to deliver like complex real-time contextual automation. This is completely in line with what people are attempting to do with generative AI and what they call agentic automation, except that enterprise web is already doing complex, multi-step and long-running processes based on context with strong IT governance. So enterprise web is already delivering an enterprise grade solution with an agent-based platform as opposed to coded agents, coded functions, using a coded DSL to do essentially simplified automations, which might be useful, but they're not going to support complex real world enterprise grade automation. So we already demonstrated our first uh, generative AI use case last May in collaboration with Microsoft. The work actually won an award. We demonstrated telco grade generative AI for service orchestration. So we were already showing complex service design, deployment, and automation with no code through an NLP interface where the developer can just talk to the system, talk to the platform to design, deploy, and manage a service. Well, we're going to do some more demos here today, and we're going to show you how we can transform customer and developer experiences with the same no-code platform. We're going to show you how we simplify and automate service design, deployment, and management, improve code summarization, analysis, and recommendations, as well as support next-gen business apps so that the apps that the developers are working on can actually incorporate advanced Gen AI capabilities, natural language interfaces, and contextual automation. Now, when we're talking about generative AI, you have to realize that people now understand that generative AI has some very powerful capabilities, but also has some concerning, troubling issues, right? It's inaccurate, inconsistent, it can hallucinate, it's expensive, it's energy and resource consumptive. There's some security concerns, IP and copyright concerns. So businesses need practical enterprise grade solutions that balance GenAI's strengths while mitigating its weaknesses. So enterprise web isolates and contains LLMs. We look at LLMs, whether it's cloud-based LLM, an open source LLM running on premise, or even a domain-centric LLM that's been trained by an enterprise customer. We support multi-model LLMs and ModelOps, but what we do is we treat the LLM as just another element of a solution architecture. We think it's a bad idea to treat the LLM as the center of anything. We don't believe that the LLM should be touching mission critical automation systems. So enterprise web is shifting processing away from the LLM. We're using LLMs in a very targeted way, and then we're driving processing back to enterprise web as a back end, where we can mitigate those concerns what we just discussed and provide better outcomes, IT governance, and sustainability. We're also going to use our knowledge graph to optimize LLM outputs. So we're going to ground the probabilistic LLM outputs with the business context, the business understanding in the graph so they can be understood deterministically, ensuring accurate, consistent, and explainable system responses. So of course, that's important to everyone, but that's not where we stop. Now that we have, we can deterministically understand an interaction with an LLM, enterprise web can use that to trigger complex automation with strong IT governance, expanding the scope of generative AI use cases. The first use case is integration and automation. We're going to show you how we use generative AI to simplify and automate complex integration and transformation tasks and rapidly connect enterprise applications both on-premise and in the cloud and even at the edge. With enterprise web, developers can talk to the platform and it dynamically generates and implements interfaces and ETL pipelines as a platform-based workflow in seconds. The use case we're going to show is a bunch of enterprise systems with customers, products, and orders connecting with a bunch of cloud-based applications that also have other information. It's going to be a bi-directional interface where Enterprise Web is going to be doing the connection, the integration, and the ETL transformations. And we're going to use the LM sort of under the hood as another element of the solution to support the NLP interface as well as some of the capabilities. So I'm going to pass this to my colleague Bill to provide the demo. Bill, take it away.
Okay, thanks Dave. Now I'm going to log into our platform and I'm going to show you just how easy we can make the developer experience. What you see here is a catalog of all of the already onboarded enterprise systems and the sources of the cloud-based apps that we want to integrate. I'm going to now show you how I can onboard a new one of these using GenAI, then compose our service using GenAI, and you're going to notice how the system will generate and implement all the interfaces and the ETL workflow on my behalf, and I'm going to show you how I can do this in a matter of minutes. Let's go ahead and get started. Onboard a new endpoint called Salesforce from a Swagger file. So now all I have to do is upload my file. The system will interrogate it for me and it will determine that it's pointing at a CRM or ERP system with whatever confidence interval. It's 94% certain. Once I confirm that, it will go ahead and map all the rest of the details.
Please use the report shown to fix the errors found during import.
Now GenAI is trying to effectively help me accelerate my job. It's just taking me exactly to where it noticed a problem in the mappings, and it can take me right to it to fix it. But I'm going to take a second just to review what the system actually did in that moment. So what it did was it obviously mapped our source to a CRM system, as we noted at the beginning. It was able to then go a little bit further and determine that there were common objects from each one of those, basically from every CRM, so that it could automate integration. It then determined, data formats and so on, so that it would be able to actually interact with this endpoint. It went further and it actually mapped all of those objects. So if you want to look at, sort of behind the hood of one of these, we're seeing that the organization customer that came through the API is going to be mapped within the system basically to all the kind of elements that are in our graph. So we can tell that what is an object ID coming through this API happens to be part of our graph related to org IDs attached to organizations with 100% confidence and so on. And this goes on forever. It's a very rich model that matches the API. And you can go through it as a developer if you want, but the system's already pretty sure about what the mappings are. In the case where it wasn't, the system actually earlier in the beginning pointed out that I had to select, in fact, a mapping here for this product. It wasn't able to determine with certainty if it was an offering or a product. So I'll go ahead and specify that one additional detail. And that's really the only work that I need to do to get this, this endpoint onboarded. Specify one of the mappings that was missing. You can see it's already flagged as valid. But let's go a little bit further here. Just see that in addition to actually mapping the objects to the APIs, it stood up and generated a set of interfaces for these. Now, they all came from the Swagger file, so they're just going to be hosted. But if this was sort of in a different kind of context, and you had standards-based APIs, even if you were working with something like Kubernetes, it would generate the set of interfaces that are needed here. So it's a really nice feature for any object that you onboard into the system. It will create an interface basically for you to work with it. Now, in addition to that, it's behind the scenes. It's actually mapping to our graph, as mentioned at the beginning. This is what enables all of the no-code integration and so on to take place. So what you're seeing here is actually how the system breaks down the elements in this particular object. You can see that it identified that there are going to be common objects from CRM systems that's going to allow it to do the integration, and then what the data formats are, so that it can basically pull the objects out of here, transform them in real time, and then push them into whatever sources is going to be needed. So this supports all of that kind of automation and sort of no-code development. So that's behind the scenes in this object. So since it's finished, we're going to send it for testing. Everything in the platform needs to actually be tested before it can be integrated. And what we have here is a DevSecOps pipeline. And again, it's all configurable. This is all within our one tool. So there's no additional testing pipelines or anything you have to implement. You can see here that it's actually stood up an instance already in a test environment, and it's mapping validations, testing reachability.
The endpoint
and so
has
on.
been published to the catalog.
Yeah, so once it finishes testing, it'll pull down that instance, and basically we're ready to go now for integration. Now, that process took me a few minutes to talk through, but really the actual work there was very minimal. That's indicative of how you can onboard most endpoints. Something with some complexity might take a few minutes, but it's just that fast working with our platform. So now that you've got things in our catalog and we've got the full set of sources, I'm going to proceed to actually composing that ETL pipeline. Show me a list of service templates.
Working on it.
Show me the graph of an ETL pipeline.
Working on it.
Add all CRM systems as inputs.
Working on it.
Add a Snowflake database as a source for customer info.
Working on it.
Add all sources of SaaS apps to act as targets.
Working on it.
Can I compose this?
Yes, all required elements are in the catalog.
Execute command compose service.
To do this, I will create a new service called CRM to Cloud Host ETL pipeline. Configure the service to use CRM sources, SAP and Salesforce, and the customer table from the Snowflake database. Configure the service to use cloud host targets, Azure, AWS and GCP. Configure the service to perform ETL transformations between CRM and cloud host catalogs. Configure the service to perform ETL transformations between CRM orders and cloud host inventories. And configure the service to display catalogs and orders in the connected customer portal. Would you like me to proceed?
Yes.
Okay, working on it.
So what we see is the system has bound all of the elements that were needed for this particular ETL pipeline. You can see it flagged them as sources and targets and what the exact ETL objects were going to be that it used. We can even see that it formed it into a graph, and at the center of the graph really is a transformation engine. So this is where the system went a little bit beyond what we just sort of explicitly asked for. It knew it was an ETL pipeline, so it needed building blocks basically from our platform services. It needed a transformation engine and a scheduler. It also attached a customer portal so that we could view any of the results if we wanted to. Now, every one of these has a sort of drop-down high-level configuration. So we're basically specifying the intent, if you want, of this service, and the system will implement it for us. So you can actually see that we wanted bidirectional mapping, so some pretty advanced features as far as how this pipeline itself is going to actually work. And if we look at the scheduler itself, it was able to infer based on the endpoints that were included that it could work in real time. Right? If we wanted to or needed to, we could override this and make it work in batch and scheduled, etc. But it's picking the the most optimized implementation for us. And then, as we mentioned at the outset, not only has it built the integrations and so on for each one of these elements, but it's actually generated and is going to implement an ETL pipeline. So this is the pipeline. What it is, it's described in what we call a state chart, so a high-level data flow process that basically describes the high-level tasks that are supposed to run. These kind of stages, if you want, are kind of a little bit linear. They're basically an organizational concept. But in truth, data is going to drive how these tasks all configure and connect in real time. And data is also going to drive, along with context, how it's going to bind to each one of the endpoints. So I don't need to tell the system how to figure out there was a difference in the AWS implementation and so on. It's going to be able to detect that for us, and it's going to do all the actual physical binding to the APIs. It's going to monitor them. All those kinds of things are just policies that we can configure for each of these tasks. But I'm pretty happy with the overall flow. And if I want to take a look at it in a sort of more, I say a simulated kind of way, I can actually look at how this thing would play out. So it's going to listen on all endpoints. They're all going to listen in parallel. That's some of the other advantages of this approach to modeling and our execution, is that each one of these is going to run in parallel, massively parallel. So if you have 10 records or you have 10,000 records, it's going to work at the same kind of speeds. So what we're going to see is that if it detects a change, boom, it's going to spawn 3 more of these pipelines in order to be able to, in this case, map each one of the individual objects, and eventually it'll update all the sources. If you want to look at this in a little more traditional way, you can see what the flowchart looks like, but no one had to build this whatsoever. This was all generated by the system based on my choices, and all of it's going to be highly optimized when it actually runs. So that's a bit of a high level. As a developer, I really didn't have to do anything. I can add additional operations if I want manually, and it'll all round trip through the UI and so on, whether I'm using GenAI to actually command the system to do something, or whether I'm clicking through the interface. But once I've got this thing complete and I'm happy with it, I can just send it for testing, which I'll do right now. And just like the endpoint had to be validated at the beginning. Before it goes in our catalog, we make sure that it runs through a DevSecOps process. And once that's validated, we'll be able to start actually looking at this service.
The service has been published to the catalog.
All right, great. So now that it's in our catalog, we can pop into it here. You'll see it is surrounded by a complete case with security and all those kinds of things that you want. But what we care about most here is the fact that we can see the state is running. And if we look at the log, we'll see a low-level trace of what it did. So in under 2 seconds here, it went from starting the service to actually, detecting something in one of the cloud hosts that wasn't in the actual catalogs, an Apache web server product. It was able to map it into each one of the catalog sources and push it in. It did this for about 10 products, but it wouldn't matter if it was 10,000. Again, it would just run this all in parallel about the 2-second mark. It would all be synchronized. And then what we have is really an ETL pipeline that's now going to run in real time with full trace through the life of effectively as long as we want to run this service with resiliency and all those other good properties that we provide. And I was able to build that without any manual integration, without writing a single line of code, and I did it in only a few minutes. Okay, thank you very much. Back to you, Dave.
That was great, Bill. Thanks. I hope everybody found that clear and compelling. Let's move on to use case number 2. Use case number 2 is code support. That's using GenAI for code summarization, analysis, and recommendations. However, with complex tasks, generative AI performance tends to decline. And code is very precise in its syntax. So we're going to use EnterpriseWeb's knowledge graph once again to optimize the LLM interaction. This way we can give a more correct, concise, and clear output to the developer. As part of this, we're going to make it easy for the developer to tune the LLM with relevant code samples and logs, etc. We're going to make that a push button function, easy to update. EnterpriseWeb is going to ingest the data. We're going to map it to our knowledge graph, tag it, and then chunk it so we can use that data in a very precise and efficient manner. This is really a form of intelligent graph RAG orchestration, again, for the maximum efficiency and the best outcomes. So beyond just static design time analysis, we're already doing dynamic runtime analysis. I'll let Bill share the details with you. Bill?
Okay, great, Dave. Now I'm going to take the role of a developer, and I'm going to show you how this tool makes my life a lot easier in my day-to-day. So here's a typical developer scenario. Someone gives me their GitHub repo for some code that I'm supposed to work with them on. In this case, it's going to be an Ansible playbook for deploying Tomcat. Usually what I'll do is I'll take this code directly and I'll import it into my IDE right away. So Visual Studio, here it is all loaded up. I'll look at the README file, and what I'll find is that the documentation is really lacking. It basically just tells me this playbook is going to deploy Tomcat. There's really no other guidance or support provided by the IDE itself, obviously. But even when it comes to looking at the individual code, trying to figure out how it works, if I click on one of these files, what you'll see is that the system will run over it, and it'll basically not do much better than just looking at it and suggesting that I use better names, which you can get by mousing over it. Not really very useful at this point. So what I'd like to do is activate the EnterpriseWeb code support to basically create recommendations for both, how I might change and fix this code, and even to go a little bit further and figure out how it can best be applied in my own environment. So let's go ahead and do that. So we'll go into, we have a simple API call here where I basically just identify the code that I want to be supported, what in this case, Visual Studio code that we're going to be working with. And then I activate a set of features. I want some summaries of code. I want some suggested improvements, detected dependencies, and anomalies. Now this can be all configured to run automatically in all cases, but it's more dramatic when I show you how it actually generates a file when I turn it on. So this will all be real time from here going on now. This service is actively monitoring the code that I'm working with here. So if I go into the recommendations, and let's just make this a little bit nicer to look at, so I'll bring it into the preview mode, what I can find is that my code summary is vastly more detailed compared to that little simple paragraph that you saw in the README. It actually goes through telling me how this playbook is structured, okay, 3 main sections, detailed accounts of effectively what all of those operations actually do. If I look at code suggestions, improvement suggestions, what I'll see here is actually a laundry list of things I can fix, right? Things that I can make better along the lines, throughout the different playbooks that are inside of this set of code that I inherited. And then if I go further down, I see things that are even more interesting. I see there's actually, the system was able to go ahead and determine what kind of code was actually deprecated. This was old code, it used things like a pseudo method that might technically be correct and the IDE will never pick up, but in this case, the actual code support is able to direct me to where to make those fixes and improvements. So this is above and beyond my sort of suggested improvements. These are things that really need to be taken care of. So let's go ahead and do that quickly here. So I'll go to the file, and it tells me to remove a couple of pseudo calls that are used here. I'll save my file, and as soon as I go back to the recommendations, what you'll find is actually that deprecated code. And similarly, there's an anomaly that was actually detected. So this is dynamic analysis. So the system actually looked at logs where I've been working with sort of similar applications. And in this case, it was able to determine that HTTP traffic, sorry, clicking on that was a mistake here. HTTP traffic was 22.6% higher on a particular host. Basically, what it's telling me is if I just change something like simply the server I'm going to deploy to, I should get better performance. So let me go ahead and do that here. And just like before, my recommendation now has been altered. So in real time, it will be making changes, even rewriting things like, where is it here? Yeah, even things like the actual documentation summary are going to be updated to reflect any changes I made. So what I get is real-time support for the code that I'm writing. I get something that's telling me effectively what it thinks my code is going to do, which is a good sanity check if it's just code that I've written. And if it's code that I'm inheriting, it's a good place for me to start to be able to understand what it is that I'm working with. And then effectively lists of fixes I can make along the way to make my code better. All that in a quick and real-time service that can be attached to any code that I write. Okay, that wraps it up for me.
Great. Perfect. Thank you, Bill. So that concludes today's demo. Thank you very much. I hope you found this informative. And of course, if you have any questions, please feel free to reach out to us. We're at www.enterpriseweb.com. You can reach out to me at dave@enterpriseweb.com. We'd be delighted to hear from you and help you with your generative AI and advanced automation initiatives. Have a good day.